100% will always make it right with the client. So I do just want to state that, like, this is not representative of our work in general, but some of it is pretty darn funny. So with that, let me first give you all a little bit of a primer on types of submetering, at least in the way that we use it in our buildings, because that's going to help these projects make a bit more sense. We have software that collects real-time data so that we can generate alerts, demand load profiles, load duration curves, things like that. And as I mentioned, we also interface with building automation systems. We do HVAC fault detection and optimization on chiller plants and air handler units, things like that. Setting resets for static pressure, differential pressure, that sort of thing. So that's what our group does. In terms of hardware for submetering, this mostly involves our Meter Insights, which is our real-time interval data platform. And there's a variety of different hardware that we employ to get data into that system. So some of it involves working with utilities to install PIBs, which is a pulse interface box. So that's something that the utility will install on their own utility meter. It has little wires, so we can connect a transceiver to it and then get that read data to a central data collector. We interface with building automation systems, especially our larger commercial clients, like think huge 2 million square foot malls, that type of thing. They will frequently have their tenant submeters tie into the building automation system because that makes it easier to compile data to bill them back their allocated utility cost. We do a ton of shadow meters. And one of the things that's driving the need to submeter so much is building performance standards. I'm sure you all have heard of them. We first started with Energy Star benchmarking that were required in some municipalities and counties and states. Now that's going a step farther. We call that beyond benchmarking because Energy Star Portfolio Manager is still a system of record. But now with building performance standards, it's not enough to report. You have to meet a certain performance metric, and you have to have whole building data to do that. And sometimes you have to become more efficient so that your score, your Energy Star score, can get high enough for you to get a building certification, which is one way you can get exempt from building performance standards. So that's another big driver. And then magnetic switch readers are something newer to us that we've been working with. That's the very bottom option there. And what we like about magnetic switch readers in particular, especially for occupied buildings, because we do a ton of retrofits, I would love it if everything we worked on was new construction. We got the blueprints, we spec'd off of that, you got the hardware in, pre-programmed, configured, got it to the GCs, they got it installed, and we could call it a day. But the majority of our projects are retrofits. So we're dealing with someone else's work, or we're going into existing buildings, and the clients don't want to turn off the water for their tenants. They don't want to take a chance on cutting into pipes. Plumbers will come in, they'll assess the situation, they'll say, you know what, your plumbing, it's like 30, 40 years old. We're going to charge you $70,000 to replumb this whole portion before we'll install this inline turbine meter for you. Or they'll come in and they'll say, ooh, you know what? You don't have enough length of horizontal pipe for the meter that you want to install. So we're going to charge you a bunch of money so that we can replumb this whole room. That sort of thing is what we see a lot. And there are things like ultrasonic clamp-on water meters that we do use in situations like that. They're expensive. They're like $6,000. Cheaper than playing. One of the first places we used it, the plumber actually quoted $100,000 to replumb. So $5,000-6,000 compared to $100,000 is kind of a no-brainer. But what's wonderful about these magnetic switch readers, when they're compatible with the utility, the water gas utility meter you're putting them on, is that they're like $750, and then you just need like a little $100 transceiver to go on top of it and something to tie the data to, some kind of central data collector. And that's it. No plumber, no cutting pipes, no draining pipes, just none of that. And so we really like the magnetic switch readers, but there are some gotchas there too, and that's part of what I'm going to talk about today. So just to give you an example of the typical submeter setup, there's really three components. regardless of what we're using in that previous slide. So in this particular diagram, it's a PIB, it's a pulse interface box that the utility put in, but it could be CTs, an electric distribution panel that run to a submeter. It could be magnetic switch readers. It could be rotary turbine inline meters for gas or turbine water meters. It could be any number of things that just collect a pulse. We need something to collect that pulse information. Then we have a transceiver, so that's number 2. There's a little transceiver then that we collect, and that transceiver is then going to transmit that information to our central gateway. In this example, it's an Xcentury gateway, but we use a variety. If we need real-time data, we tend to use Leviton or Jenny's or like obvious aqua suites, things like that. But you need a gateway, which is going to collect that information and push it somewhere. So in the case of Xcentury, they're pushing it to their own Xcentury portal. We have an API that goes and grabs the data, pulls it down. For Leviton aqua suites, they tie directly into our system. So it's like real-time data. When we were working with UC Berkeley, we ran this on their cogen plants, and we literally had to have minute-by-minute updates on their data. And so just depending on what the client requirements are, that's what dictates the kind of gateway that we use. So that gives you an example of the kind of hardware solutions that we are employing in these projects. Now, some slides I put in this deck, knowing that it's going to be distributed afterwards, that I'm not going to talk through, but I just want you to be aware that data is here. And this is one example. So these are the pros and cons of different kinds of hardware. And we had a client ask for this. We put it together for them. And it is the #1 requested document from all of our clients. They all love having these different types of hardware simplified. You know, where can you use it? Because as much as I love magnetic switch readers and their ease of use, they're not revenue grade. So if that submeter is being used to bill back a resident or tenant for utility costs, you can't use it. It's not approved. So there are little things like that that you have to know about each piece of hardware. And so we've outlined that here with the pros and the cons to kind of help our clients understand as we're sitting together trying to spec the most appropriate hardware for their particular situation. This helps them understand why we spec what we spec. So there are a few slides here that have this detail on them. Just as something that if you're interested, when you get the slide deck, you can feel free to go through and read it or use it or whatever you'd like to do. It's nothing official. It's just something my team put together that we make client facing to help them understand some of the decisions that we make and some of the questions we're going to ask them as we go through and spec a project. All right, so let's get into the first use case. And I am not going to be able to not laugh when I go through some of this. The first use case is an industrial building, and we needed to collect whole building data for their ESG reporting. So didn't have to worry about, a gateway that needed to have, real-time interval data, didn't need to worry about revenue grade meters for billing back tenants for utility costs. And so we were going to go with the magnetic switch readers for water and gas. But this is our very first time using magnetic switch readers. And actually, initially, we were going to go with just the regular inline water submeters that we typically use for water and gas. And these are smaller pipes, like 2-inch water pipes. And so what happened was, and I was joking with MiraZoom, so our team, all of us on the engineering team, when we say what happened was, because you're going to hear me say that many times in this presentation, it's like the professional version of hold my beer, meaning we're about to share something we knew we shouldn't do and was a bad idea, but we did it anyway. So when I say what happened was, now you know, I'm about to tell you we made a bad decision and we did something pretty dumb. So here's what happened. We let our client pressure us into using these magnetic switch readers because the preparation for the project and really the legal part of the project, negotiating the contract terms, took way longer than anybody expected. And so what happened was for whole building data, you're up against a deadline. And for ESG reports like GRESB, if you're familiar with those, you can only estimate 20% of your consumption. The rest of it has to be metered data. So you have this window where you got to start early in that calendar year collecting actual meter information in order to meet those thresholds for your ESG reports. And so we were up against a wall where the legal stuff took forever, the speccing took forever, the site assessments took longer than they were supposed to. And we wanted to install a traditional meter that we were used to, but the client said, nope, it's going to be way quicker, which is true because we weren't going to need plumbers, and that was the huge limiting factor. So we went with magnetic switch readers using the client site for R&D, which is just as bad of an idea as you think it would be, and honestly, probably even worse. So here's what happened. We had two problems. Ultimately, what we found out was magnetic switch readers don't work on cast iron water meters. It's one of those things I just, it's such a common sense thing, right? It's like physics 101. Come on, of course magnetic switch readers don't work on cast iron, but we didn't give it any thought. So for months and months, multiple visits, we're going out trying to figure out why these sensors, they worked on one meter, but they didn't work on the other water meter. And they were fine on gas. We couldn't figure out what's going on. And also these meters are down in the bottom of a 10-foot pit with like a 1-inch steel metal cover over it that literally takes 2 people to lift. It's on hydraulics. And so we couldn't, the transceivers that are in the pit, which you're seeing there, they couldn't get a signal past the lids. We really had 2 issues we were trying to work through. So here's what happened. When I say we, I mean like our engineers made 9 visits out to that property, and thank goodness this particular site was unoccupied. We ended up trying 3 different transceivers, thinking maybe the issue was the initial transceiver that we used was not strong enough to get the signal, so we switched to a more expensive one. We also switched out our gateways, thinking, okay, maybe the problem is the gateway. Maybe the first one we got is a lemon, but we switched to a different type for the second one. When that didn't work, we went back and we put a repeater in right next to, just right inside the building, but as close to the water meter as we could. And we went out 2 times to move it. At the end of it, we reached out to Alex, who's the CEO at Vodiverx. That's who made these magnetic switch readers we were using. We sent him some pictures just out of desperation. We're like, oh, we cannot figure out what we're doing wrong. We can't figure out why this one won't work at all. That one works. We set them up exactly the same. No matter what we do, we can only get a signal out when we open the metal lid, which, yes, should have been a good cue for us. And so Alex, who's an engineer, the CEO of Vodiverx, luckily is an engineer, he quickly ascertained the problem, wrote back and said, well, magnetic switch readers are not going to work on cast iron meters for a reason. And we just, wow, yeah, we were pretty embarrassed. So our company ended up eating all of the installation and hardware costs for the water meters. Uh-oh. I don't know what's going on with Teams. That's weird. Sorry, I don't know what happened. Let me go back to my presentation.
Just reshare, hopefully it's gonna work.
Yeah, let's see, let me go back here. All right. And I'll share again. Let's try that. I think maybe just Teams restarted itself and decided it wanted to be the front runner. Let's see. But I cannot get it to go away. Hold on. All right, now let's try it. I might just have to close it. Let's see if this works. Ah, here we go. Okay. There we go. Okay. So as I was saying, so we ended up paying for all of the meter hardware costs for water. Of course, 7 of the 10 visits to the property were comp. 2 of them were legit. One of them was to meet the electrician there for the original install. One of them was to go back for a commissioning visit. So those were legit. But 7 of our engineers' time, those visits to the property were comped. The cost of all of the repeater in both gateways plus the transceivers, and this is the one that hurt the most, a full year of software license fees because the client didn't have access to their data to view the whole time we're fumbling around trying to get these magnetic switch readers to work. So we're going to back up and see what exactly did we do wrong. We did a lot of things wrong. One was for the site assessment, we didn't provide a full questionnaire for everything that we needed. We kind of made the assumption, and this was probably 2 years ago, we made the assumption that the company that we're working with, we'd worked with them for years. They're sending out someone who's going to be highly skilled, very experienced, and would know some of the normal things that you would want to collect. If you're putting CTs in an electric distribution panel, you need to know the voltage and the amperage, and are you metering at the panel level or the circuit level? How much space do you have? Can you use regular CTs or do you have to use Rogowski coils? Like those types of things with lots of pictures, because anybody who's even done ASHRAE level 2 audits knows you photograph and video everything, because you don't know when you get back to the office what's going to come up later. I'm in my 50s. I've been doing this for a while. Pictures and videos have saved my butt many times. So we didn't really stress that with the company we sent out to do the assessments because we just thought that was a given and anybody would know that. And we've had success working with them before, but that was our bad. That was our mistake. And we also, because the site assessment was going out to look for installing inline meters, not magnetic switch readers, things like what is the water meter made of, what kind of lid is it, like those kinds of things were not even on the assessment. We didn't even think about that. What we also found out was that the company sent out electricians who are not plumbers, and they don't know to think about things like how much horizontal pipe do you have to even install an inline water in to begin with. Rule of thumb is you want 10 times the diameter before the meter and 5 times the diameter after the meter, plus you've got, the length of the meter itself in order to figure out if that's going to work. And you can only install turbine meters horizontally, whereas ultrasonic clamp-ons you can also install vertically, like things like that. We did not include, we didn't prep them on that sort of thing because we thought we had the solution figured out. We didn't ask them to collect that stuff. They didn't take pictures. So we didn't have any information when the client wanted to switch to magnetic switch readers to even go back and look at photos to see, okay, what do we even have here? At the time, it wouldn't have mattered though, because we didn't even know magnetic switch readers wouldn't work with cast iron meters. Anyway, so, we let our clients' timeline and the pressure they were facing dictate what we did with the hardware and pressure us into making a very, very bad decision that we ended up paying for. I mean, even though we were very upfront with the client and said, hey, we haven't used this equipment before, you're going to be a guinea pig on it. And they were like, hey, that's okay. Sign us up. Let's go. Let's move forward. They didn't end up paying for the equipment and all of that time. We did. It's us that ended up paying for that decision, not the client. And we didn't really fully educate ourselves on the magnetic switch readers before we went out there. We just read what was available online. We read some cut sheets. We read some installation instructions. So here's some things that we also didn't know about these magnetic switch readers. They pulse 300 times a second. Who would have ever thought that would be a thing or need to be a thing? Because we certainly didn't. We didn't see it in the literature. So our data collector that we installed had a limit of 16 million pulses, and within 3 months, it maxed out. So we had to buy a little piece of software, VadaWorks software, install it on our laptops, which is a chore because our company locks down our laptops. Yardi, our flagship software, is finance and accounting that Fortune 500 companies run on. So you can't install anything. You can't even access your USB drives. Like, it is locked down. So that was a headache, working with IT, trying to get a laptop where we could even install this software so that we could go reprogram those magnetic switch readers to do fewer pulses per second. So we didn't have to change out the gateway again. And then the other thing is that you also have to program magnetic switch readers so that it knows each pulse what is that? Is that 1 gallon? Is that 10 gallons? Is that 100 gallons? You have to tell it. It's kind of like a meter multiplier for submeters, except they call it a K factor. But that's got to be programmed in. And when you're at an unoccupied site where you can't run water because the water's not turned on, you can't really calibrate it. So then there was a period of time where we had to wait for some tenants to move in, get the water turned on so we could go back out multiple visits with multiple people, because it takes 2 people to lift that lid before we could finally get that commissioned. So here's another example of some things I threw in, just so you all could have them to reference if you want after what I have to say, if you trust them. But these are the site assessment forms that we had gone to. So these are the ones that after we went through this whole process, we went back, we revamped these, and this is what we use now. So just kind of sharing the fruits of the lessons that we learned from this whole process. So here's what we changed going forward. We update our questionnaire, as I just showed you, with way more information. We're not taking anything for granted. We're not assuming anything is common sense, just like the fact that magnetic switch readers don't work on cast iron. We also require our contractor who's doing the site assessments, electricians, plumbers, whoever they are, they have to complete that questionnaire and get it back to us. Because what they were doing was just writing their own notes, sending those to us, and then we'd have to try to take that information and put it into our questionnaire, even the more basic one we had previously. That's when we'd find out they didn't look at everything. They didn't collect all the data that was in the questionnaire, but we don't find that out until they've left the site, because they didn't fill out the questionnaire, which is what they were paid to do. So we weren't really forcing them to follow the project spec, and now we do. So that helps things as well. We also more carefully vet. We ask questions. Who's going on site to assess? What is their background? Because for commercial and the stuff that we're working on, rookies can't usually handle it. It's nothing against people who are inexperienced, but until you know what not to do because you've been burned a few times, there's some things that you just can't be prepared for unless you've been there and you've done that. You know, for you go to a site and you can't find the submeter, and that's because it's up under the drop ceiling. Or you go to a place that's like a mall with restaurants and retail and whatnot, and that submeter's up above the prep center for a restaurant. Well, you can't do that assessment until after they close or before they open. So little things like that you think are not a big deal, but they add up to a lot of project delays and costs. Someone has to pay for someone's time. And also, electricians cannot spec jobs for plumbers and vice versa. So those are some things too. And then the other thing is, we just don't let a client pressure us into R&D ever. You know what? We let them know for their timeline. We're very clear up front. Hey, look, if you want to have this equipment installed, you know, here's the average hardware lead time. Your legal department, we got to have a signature on this contract by this date in order to get this done. If it's not done, then I'm sorry, we can't meet your deadline. And we let them know that 6 months ahead of time. So we are very, very vocal in letting them know what their deadline is that we're working with for the kind of hardware that needs to be installed. And we never, ever, ever do R&D on a client site again, ever, ever. Okay, I'm so sorry. And Mirazun, feel free to interrupt me. I'll try to speed it up. Sorry about that. Oh, and Veronica, awesome. Okay, so the second site that we're going to talk about, let me move my, sorry, I've got this black box over here. It's a multifamily site, and for them, it was building efficiency that they were working through. So a lot of our clients have public ESG goals, sustainability goals, net zero goals, things like that. And so for this client site, for just their common area meters, they were wanting to do some shadow meters on that. Then they did have some tenants that were directly metered by the local utility, but some weren't. So there was some tenant submeters that need to be installed as well. But for those, they had to be revenue grade because they were being used to bill back utility costs. So many things went wrong on this one too. We were initially supposed to be doing electric, water, and gas submetering. What happened was, when I say we, and in this case, it wasn't our engineering team who worked on the project. It was another adjacent team that usually handles multifamily, but they just hold that thought. Put a pin in that. We'll get there. So the Yardi group that ran this project let the property staff drive the project, let them change the scope multiple times, actually. And in terms of the company, the subcontractor that was supposed to go out and do the site assessment and then come back and install the meter, it's never a good idea when the electricians and plumbers who go scope the job and do the site assessment are not the same ones who go back. And we're going to cover why in just a second. So we had two problems here. One was that client corporate and client property staff were not aligned. Corporate was saying want electric, water, gas. Then the plumbers, electricians would get out there and the property staff would say, no, 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 we don't want electric and gas. We only want water. Well, then they said, no, actually, we want to keep our water submeters, but we just want to put transceivers and a gateway in. And then when it turned out that some of those water meters couldn't just take a transceiver, they're not that kind of water meter, you have to replace them. Then it was like, okay, well, let's replace all of the tenant submeters and add new tenant submeters where we don't have them. Then it was like, nope, don't do that. Actually, all we care about is common area spaces that we can control, and that's all we want to submeter. And so that was an issue, but also we let the subcontractor off the hook. We did not manage them the way they should be managed. And part of that issue is just the fact that we hired a sub who hired a sub. And so there was no clear ownership of the property, the project. And so when there is no clear ownership, that means nobody owns it, essentially. The sub sent great plumbers and electricians to the site. They were there for like a week, going through everything. Property loved them, knew what they were talking about, veterans on the job. They basically sold it. And then when it was time for the installation, they sent a rookie, like, and no offense to anybody in their 20s, but I guarantee you everybody on this call knows not to do this. He would show up, talk on his cell phone, in front of the property staff, talk about he was going to try to cut out early or talk about going and getting drunk the night before, just very unprofessional and sort of young and immature. And the property just hated him, basically. And so that was not a good look. But for that poor guy, and in some ways I feel sorry for him, he showed up on site for the first day and called Yardi and said, hey, I'm here. What am I installing? What am I supposed to do? And we were like, what? Your company did the site assessment and the speccing and created the bill of materials. We ordered and programmed what your company told us to do. Call your company and talk to them. Well, he did, but it took him a while to reach the right person. And so a whole day is gone at that point, right? So this is what I mean by holding your sub accountable, keeping communication going, because the other problem with hired a sub who hires a sub is that all of these important things that happen when that electrician or plumber gets on site, like the tenant not allowing access to their units because they weren't notified of an assessment by the property. Well, that is like a game of telephone. So the plumber, the sub, calls his boss, leaves a voicemail. His boss eventually gets that voicemail, calls the sub that hired them, leaves a voicemail. They eventually get it and call Yardi. It's like 3 days later by the time we find out that there's any kind of issue. And as much as I know the group, the Yardi group that was managing it, I know they've reached out to the sub and tried to work directly with them many times. But it wasn't Yardi that was paying them. It was Yardi sub that was paying them. So it was a big just mess. And then what would happen is the plumbers and electricians would get on site. The property staff would say, nope, we're not doing electric and gas. All we want to do is water. As I mentioned, changing the scope constantly. And we let them, Yardi, not our team, but the Yardi team that was doing this, let them, but still tried to keep the same timeline. So they weren't properly managing the clients. And you all know how difficult that can be, but it has to be done. So, yeah, but the good news is there was no problem with the hardware this time. It was the installation of the hardware, but the hardware itself worked fine. So that's the good news for this one. So here's what happened. It took 2 years just about for just the water submetering portion only to get installed. And part of it was the client did change the scope 7 times. First it was electric, water, and gas, then it was water, all meters, then water tenant submeters, but in there somewhere they just wanted the transceivers attached to existing submeters, and then they found out that some of those submeters couldn't take transceivers. Then corporate got involved and said, hold on, it's not just water, it's electric and gas too, but we really want to focus on the common areas. So it's, you know, our utility meters that we want to focus on first, because this is an efficiency project, right? Then it expanded to water all meters because, wait, hold on, we still have the problem. We've got to bill back tenants for their portion of the water utility cost. And now I just met with this client today. In fact, we're back to electric, water, and gas, but utility meters only. And I had the property staff on, the regional staff on, the corporate on, my boss on, and Maria, who manages the engineering team that's going to support all of this, all of us on as we went through meter by meter. Is this meter part of the scope? Yes or no? Check. Literally took an hour and a half to do that on 25 meters today. It was kind of crazy. Anyway, the other thing though is that the team that was working through this project, they usually handle multifamily, and it's completely different animal from commercial. And as I mentioned before, commercial hardware, especially retrofits, are just their own beast because everything is bigger, everything takes longer than you think it will. We're dealing with 480 volt electric distribution panels. The water meters are bigger, which means, you know, they might usually spec a little inline turbine water meter, but anything over 2 inches, you really don't want to do that because it's a maintenance headache. You really want to do something different, but they don't know that because they don't work a lot on commercial. The other thing too is it's different scheduling, site assessments, and installations around commercial tenant hours than it is multifamily resident unit visits. Completely different. And then sometimes there are things like lift required. But the other thing is that, and this is regardless of the type of job. So one of the other issues, and I think it's in here somewhere, is that we require someone from the property. So a client representative has to be with us at all times. And we do it for liability reasons, but we also do it because what if a piece of equipment ends up, someone later notices it's damaged or something was stolen or it's missing? We need to make sure that Yardi doesn't get sued, doesn't get blamed for something like that. So we have to have staff with us, and it has to be part of what is arranged. And that was a big issue too. So what did we end up doing? I had to step in and have some very tough conversations with everybody involved, including people in my own company. We are letting them finish the water submeter installation. So we're letting them finish what they started. But the whole project, electric, gas, and some residual water meeting for the rest of the project is coming to our engineering team. So for all commercial jobs, going forward for this and all clients, they're going to be handled by our commercial team. The concessions were that all the water hardware was provided at cost, half of the installation costs were comped, and the client didn't pay software SaaS fees for a year. That hard conversation I mentioned I had to have from the lessons learned, this is it. So I had to talk to the client about their scope changing so many times and why. I had to talk to them about that they would schedule their maintenance guy to not come in until 10 a.m., take a 1 hour lunch and leave at 4 p.m., which meant our plumber could only start work and work between 10 and 11, couldn't work between 11 and 12, and then could work between 12 and 4, and then had to go home because he had to have a member of the staff with him. So, you know, that was an issue. So all of these different things, I had to have these conversations with different parties, understand what happened, make sure that we had a plan for how we were going to do things differently with the next projects. And it's not fun, but sometimes it just has to happen. So what we change going forward, all commercial projects, our engineering team is handling. We implemented a much more stringent PMO. And I mean, we documented the heck out of that thing. We do project charters now, which I'm the sales engineer. So I write up the project charter, which captures, in fact, let's just go forward a little bit, which captures all of the relevant information on the project, the commitments I've made to the clients, the goals and constraints the client has, including any deadlines, times, things like that, what they want to deliver, why are we submetering? Because again, whether we're submetering for billing back utility costs or whole building data or building efficiency directly dictates the kind of hardware that we can even use on these projects. And then the client business case, like why do they even want to do this? Because that helps us to know too. Then we go through all of the different stages of a project and we line out exactly what we're doing, all of the requirements that we're collecting, the deployment phase, assumptions, constraints, high-level risks, all of this. And we'll get back to the engineering drawings. I'm going to go back. And so that's one big piece of the PMO that we've implemented, but we also either have now project blueprints, construction blueprints, or completed questionnaires that the engineering project manager, who's going to be taking over the implementation of this once the contracts are signed, he's got to have a really clear handoff with all of the information he needs to run the project well. For retrofits, always photos of the site assessment, full set of the engineering drawings that we do that shows where we're going to install that equipment, electric panel schedules and which circuits get mapped to, and we'll get back to that, but which circuits get mapped to which submeters, and signed copies of all agreements. And I didn't put this here, but the proposal as well. And then we make sure we have calls with corporate and property level representatives so that everybody stays on the same page, because yesterday with this client, a property manager reached out to me and said, oh, are we going to go start our site assessments for water? And I was like, yeah, no, actually we're doing electric and gas now. And I'm talking to your VP tomorrow and I will get back to you on that. We just had that happen. It's just so funny. Anyway, so there's the project charter. Here's an example of our engineering drawings that we do to make sure that the electricians and plumbers know where to install things, but also the engineering project manager gets all of this as well, so he knows what the project is all about. Let me do a time check. How am I doing, Mirazun? Do I have time for the third one?
Yes, you do have time. No worries.
Okay. So this is a treat for you, Mirazun, because this is different from the one that we talked about previously. So this is a large multifamily energy efficiency. For this one, so we used to think that it was a great thing to have the utilities install PIBs on their utility meters because it tends to be cheaper. And sometimes if plumbers or electricians, their availability is a limiting factor, a lot of times the utility can get out there quicker. So it's kind of a win-win all the way around. But in this case, that is not what happened. So what happened was two problems. One, we did go with the utility installing PIBs, and this was a municipal utility who installed PIBs on water, gas, and electric. The problem was that the client, the facility manager at the site, really wanted to own this project and didn't really want Yardi involved at this phase. And so that facility manager, who's not an electrician, was talking to the utility. And whenever the utility's putting in PIBs, there is some electrical work that has to be done. It's prep work that has to be done. Then the utility will come put their PIBs in. But the facility manager didn't really understand what the utility was saying had to be in place before the PIBs could come out. So the utility ended up coming out multiple times to install PIBs and never could because the right electrical work was never completed. And we should have stepped in. We could have gotten it. The utility didn't want to talk to us without an LOA, which is understandable. This is our client's meters, and someone third party can't just ask the utility to install a PIB on a meter they don't own. So with an LOA, we could have stepped in, talked to the utility, found out, basically translated and found out, okay, what is it the electrician needs to install for you? Then we can work with the client, give those direct instructions to the electrician, get all of that groundwork done, then the PIBs can get installed. But we didn't. And the client was at their wits' end, but it gets worse. So here I'm explaining kind of the economics of a PIB and why we and clients tend to like them. It's just in this particular situation, they didn't work out real well. But when they do work well, it's great because then the utility comes, installs the PIBs. We just attach a transceiver on a little wire that they leave for us. And then that transceiver can send the data to the gateway. The facility manager, we really tried to respect that he wanted to run the project. And we didn't want to rat him out to the property manager and kind of, embarrass him, the project manager on the Yardy side that was running this, not on the engineering team, the other team, was friends with the facility manager and didn't want to make him look bad. So we let this drag on way too long. Then that facility manager literally had a heart attack. He had a heart attack. He retired. The new facility manager had no idea what was going on and was a little bit over his head. He kept putting the project on the back burner while honestly, in all fairness, he's getting his arms wrapped around a new building to him, trying to understand and get other things that were higher priority done first before he circles back around to this to figure out what's going on and basically learn something new because he hadn't worked on a project like this before. It wasn't until corporate went to compute the greenhouse gas emissions for this property and saw that those numbers were very, very disappointing and they were going to miss some published reporting goals that they had, that we got brought back in by corporate to say, hey, what's going on here? It's taken forever and we're not going to rat out the property. That's why there's no client names here. I don't know where this presentation is going to go when you guys send it out. There's no client names in here so that nothing can come back to Yardy. But that's why the corporate reached out to us, is because there was a problem and it was a little bit embarrassing that they were missing their targets. So they brought us back in. We got an LOA. We worked with the utility. We got the electrical stuff done. We got the utility out. They installed their PIBs, but it took over a year. Clients frustrated at everybody. Clients, sometimes do that. They don't necessarily discriminate, but it was fair to be frustrated with Yardy too. We did still need to come back and install some sub-meters because utilities won't necessarily install a PIB on all of their utility meters because not all of them are PIB ready or PIB compatible. So we did have to come and install some sub-meters, but it had been so long, not all the parts we had originally spec'd were still available. So we had to respec the job. And then to kind of, as an olive branch peace offering, took the property manager and the new facility manager out to a very nice dinner, bought them some really nice wine. And that's how we went through. And when we went through the project closeout documents, was over a nice dinner that we felt we owed them. So we stepped in eventually to help out, but we let it go way too long. So in this case, our failure wasn't because of something we did do, it's because of something that we didn't do, but we did make it right. So we didn't collect any of our SaaS software fees. Unfortunately, for a while, the rest of the portfolio business was put on hold while they were figuring out whether or not to continue with us on this. But we worked really hard with that new facility manager. We talked to him. We had a guy local who took him to lunch a few times. We educated him as we went. We kind of gave him some special attention. He has become an advocate for us, and the project is now back on track. So what we changed going forward, as I mentioned, there was another team that was doing this, but just due to the complexity, our engineering team is now handling it. But we own every project we touch. It's not okay to say, well, someone else is doing part of this project. We're going to sit back and just wait and let them do their thing. And then, when they're done, then we'll come in. Because, sometimes, as we've seen, that doesn't work out. We really need to step in and kind of own the project and help. When we can clearly see something's failing and we have the expertise to step in and help, it's really our responsibility to do that. It's our client. But the other thing too is when a project takes so long, there's so many things that change in a property over that course. And it's even, we've had this happen even on commercial, not this specific thing, but be a long lag time between when we spec hardware on commercial and when the client's actually ready to roll it out. You've got tenant improvements that happen. You've got all kinds of things that change at that property over that point where what you originally spec'd might not still be appropriate or even in some cases available. We've had where hardware is no longer available. For this project, they did some new residential amenity build outs. And so we had to add some more sub-meters. They installed solar. We needed to add some sub-meters for those, but we made that more of a phase 2. And then some of the original equipment we spec'd, it was discontinued. So we basically had to do a hardware spec refresh, and that just happens. But at the end of the day, it all turned out all right. So as a wrap up, What have we learned? I'm hoping you can learn from Yardy's mistakes. And I want to repeat the disclaimer I said at the top. The majority of our projects go very smoothly. And part of that is because when we do have mistakes like this or things that just go south and don't go well, we do take the time to dissect them, understand what went wrong, and have some lessons learned and change how we do things going forward. And so some examples of that are more effective project management, implement your PMO, be strict about it. It's not enough to put something in place and have a pretty shiny document that says this is your process. If nobody follows it, you have to follow through. It is time consuming, and sometimes it is so freaking boring to fill out all of those forms. I know what this is because I've been talking to the client forever about it, but that's not the point. The point is the other engineers who are going to be taking over support or installation don't know. They haven't had those conversations with the client. So I have to complete all of this to make sure we all stay on the same page and everything is smooth, project smooth for the client. We are very careful about vetting our site assessors now. So we make sure that they've got the right expertise that matches the job that we're wanting to do. We manage our client's scope. So in the project charter, the client has to note when the scope changes. We'll have multiple versions of that project charter. And you do your R&D on the test bench. You don't do it at the client site, as I mentioned, but also you have the project spec'd and managed by the team with the expertise that best fits that project. So a team that usually does multifamily water meters should not be speccing commercial electric and gas. And communication. I mean, there's so much that communication can solve with this stuff. If we had just communicated with the client, got an LOA, reached out to the utility, we could have really sped up and made this a much smoother process. Communicating, helping the client because they have disconnects a lot of times. We can help them by communicating and bringing the property level staff and the corporate level staff together. And then communicating within our own teams too, with our PMO documents to make sure that what I sell is what gets implemented and the client's happy at the end of the day. So I know that was a lot. Let me just pause and say thank you for having me and see if there's any questions.
Oh, thank you. Thank you for the presentation. We are almost out of time, but does anyone have any question? Is this presentation will be available so I can send it to the participants? Okay, that's
yeah.
awesome.
So Mary Sue, I thought I would send you a PDF version if that's okay.
Yeah.
This evening. Okay, perfect.
That will be totally fine. Well, if no one has question, I was wondering why you think industrial customers would like to have magnetic switch reader instead of, just like a regular meter. What's going to be the benefit that you guys show them when you start building your project?
Yeah, so there's two main benefits, especially if a site is occupied. So magnetic switch readers, hardware wise, are slightly more expensive than like an inline turbine water meter, as an example. They're a tiny bit more expensive, but you don't have to have a plumber to install them. You don't have to cut into pipes. So magnetic switch readers, literally just, it's a sensor that straps to the side of the face of the meter, and then you just attach a little transceiver. Anybody can install it. Doesn't have to be a plumber. So in our experience, especially with commercial sites, plumbers will come in if you want to do inline meters and they say, oh, okay, it's going to be a $30,000 job to do that. Like it's the plumbing costs that are expensive. It's not the hardware. So there's that. But then in addition, when you are trying to meter a space that's occupied, you just shut off the water. So if you've got a restaurant or residential too, but really for commercial facilities, a spa, a restaurant, like you've got a property with like different kinds of commercial or retail, and they're all needing to use water at a different time. Literally the only time, a bar even, the only time you can turn off that water is like between 2 a.m. when that bar closes and 7 a.m. when, the attached grocery store opens up, right? You've got this really small window. It's really tough to find a time when you can shut off the water. So it solves a lot of problems and it's very cost effective, but magnetic switch readers aren't compatible with everything.
So essentially it attaches to the side of the meter and it's reading some
That's right.
spinning gear that's
exactly right.
inside the unit.
That's
Interesting.
exactly right.
And then from
Yeah.
there, your hardware interprets the pulses and calculates out what the flow is
That's
or what the
right.
volume is.
That's right. That's right. Yeah. So we then attach a little transceiver to it, and then that transceiver then sends the read to a central gateway, and that's how we get our data is from the central gateway.
Is the mathematics handled at the far end in the cloud, where it's actually doing the data acquisition and calculations of that?
No, it's actually handled. So the installer there's a little software package that the installer will use. So they'll plug it in, and it's like a little fast form. You can think of it that way, where you'll plug in specific little information. And this is where it's difficult if you're like, for us, the first time we did this, it was at a site that didn't have the water turned on. So it's difficult to really commission while you're there, run water through to see how much you're running through so that you can properly set that K factor, because you do that while the magnetic switch reader is plugged into your laptop. So that is maybe one downside, but any piece of hardware, you have to be there physically to install anyway. And whether it's configuring a transceiver to a gateway where you need to physically be there, or for example, installing this magnetic switch reader and running water through and installing the K factor, there's always some part of that setup and commissioning that has to be done on site. And that's just how it is. It's not, though, what is nice with submeters and like meter multipliers, you can do that when you get back to the office. You can log in and you can make those changes, but you can't do that with magnetic switch readers.
The other term that you used was the PIB for the submetering of the electrical. What is that? I still don't understand what that is.
Yeah, so a PIB, it stands for Pulse Interface Box, and it's like a little nodule that the utility installs. So a utility is who would install a PIB, and they install it directly on their utility meter. It's got some little wires that come out that you can attach a transceiver to collect that pulse. So that PIB is what's generating the pulse that the transceiver is going to collect and then send to the central data collector. And it's a little inexpensive device. A lot of times, if you're working with a utility that kind of has it together and is pretty good at getting these things installed, has enough staff to get out and do it timely, it's a real cost-effective way to go, even cheaper than magnetic switch readers, really. You know, you're looking at maybe $400, $450 California dollars to get something like that installed on a lot of meters. It's not very expensive.
Okay,
but
so
the limiting
basically
factor
it connects to utility meter, so you won't be connecting it to any branch circuit or anything like that. So you'd have to have a meter in there to do it. Okay, I got it.
Yeah, exactly.
I've done a lot of commercial metering, and I guess I'm just not familiar with those terms.
Yeah, you know, because you can't touch the utility meter, right? You can't install anything ahead of it, only after it. So the only person that can touch the utility meter is the utility. So they come in and they attach this device on top of their own meter and then have some wires that we can use to collect the pulse readout.
Got it. And then that data gets teed up to a dashboard and all the calculations are done there.
Exactly.
Understood.
Yeah. Yeah. And so what's nice is everything that we install, and a lot of companies nowadays install things with open communication protocols. So, you know, if you have your own dashboard, send the data there. If you use somebody else's dashboard, send the data there. You know, that's the nice thing these days is these dashboards and the hardware that feeds the data into them. It's pretty open these days. We don't run into just a whole lot of closed systems. It's kind of a nice way, because I wouldn't say that was the case 10, 15 years ago, right? We had a lot of closed systems 10, 15 years ago, but now everything's pretty open.
Do you see a lot? Hey, Mirasoon, I've got a question. Do you see a lot of difference between, for example, a large commercial and a public sector client in the types of submetering that they would want to see?
Yeah, not really, from the perspective that there's three reasons that any building is going to submeter. Either they need to collect whole building data, they're concerned about some kind of efficiency. I mean, I think about like universities as an example, or they need to bill back. You know, so in the case of, you know, residents, multifamily, it's residents they're billing back. For commercial, it's tenants they're billing back. For student housing, it may be billing back students for their portion of utilities. We work with companies that run a lot of university student housing. Military is a huge client of ours. Same kind of thing, right? They've got to bill back their servicemen and women. So those are the three main reasons people submeter, and it pretty much affects everything across the board. It's one of those three reasons you're putting submeters in.
Excellent, thank you.
Oh, what is the typical lifetime for these devices?
That's a good question. So there's the warranty period, and then there's the typical lifetime, which which usually lasts much longer than the warranty period. So we'll use like water inline turbine meters as an example, because those are super, super common. Anything less than a 2-inch, you can probably get 10 years out of that. But what you have to be aware of, and this goes back to why you're using the meter, if you're using that meter to bill back a tenant, then as that meter slows down, you're still getting the same cost, but you're billing less of it back to the tenant. So you're actually losing money because it's not recording as much consumption as it should be. But if you're using that same meter for whole building data, then yay, because that's reporting less consumption. So your EUI, your energy use index, looks better, right? So it depends on what you're using the meter for. But 10 years, and water meters with mechanical parts always kind of slow down. But if you get to something above a 2-inch for a turbine meter, like a 7-inch or a 10-inch, what you look at is a warranty that's maybe only 2 years, and every 2 to 3 years, you've got to go in and replace some of those internal parts, which is like half the cost of the meter. So that's why you see like utility companies themselves, they're moving more to ultrasonic versus these turbine meters for these big utility meters on these huge pipes, because the maintenance costs are just astronomical. So for those, a warranty of 2 years, and you maybe have 2 or 3 years before you have to start replacing parts. Magnetic switch readers, I haven't seen much in the way of literature, and honestly, for us, it's too new to really guess, but there's no moving parts. It's a sensor that's just attached to the side of the meter itself. So I've got to think it's more the electrical components being sort of outdated that's going to govern the lifespan of that versus anything like with a meter that has moving parts that wear out over time. And then ultrasonic, man, those things, ultrasonic clamp on, for an example, they may last 20 years. I mean, and they stay very, very accurate, including small volumes, big volumes, but you pay for that because they're really expensive. And then CTs, forever, until you tear that building down, basically. We don't have a lot of issues with CTs.
Yes. Well, we are over about 10 minutes, but thank you so much for your time. Is anyone else has any question? I'll stop recording.